Okay, so I'm going to explain inverses in a little bit different way. So let's say, I start at my house and I want to get to, I don't know, the grocery store, Staters. The grocery store. Okay, so I go out of my driveway, I go down the street, I turn right, and then eventually I get to the parking lot and I turn left. Okay, something like that. That would be then the function. To do the inverse, we're going to go the other way. So I'm going to go out of the drive or out of the parking lot. I'm going to turn whatever way that is. And then, and then I'm going to turn this way, and then I'm going to go back into my house. So that would be the inverse. Okay? So the function does something, and then the inverse undoes it. Okay, so let's look at something. Let's say I want to take a number. Let's say my function is, I want to take a number and I want to add 5 to it. Well, then the inverse, which we would write this notation like this. So f of x equals x plus 5. Inverse of f of x equals x minus 5. Okay? All right, so, one function we're adding 5, and the inverse, then we're undoing that. We're subtracting 5. Okay, so if that doesn't make sense to you, that's okay. We're going to go on, and we'll talk about what this means. So for inverses, there's another property. If you take f of f inverse of x, okay, I would probably use brackets, but they use parentheses in the book. That has to get you just x. So it's a composition. You're going f compose f inverse of x. That has to just equal x. So you have to get back to where you started from, okay? So you could think about, in the morning you get up, you put your socks on, then your shoes. At night, you take off your shoes and then take off your socks, right? And you're back to your bare feet. Okay, so another example. Okay, so that has to be true. It also has to work the other way. So you have to be able to go f inverse of f of x, and that's going to just equal x. And you can write that the same thing here with composition notation, f inverse of f of x, and that has to get you just x. Okay? So how we verify if two functions are inverses, we do these compositions, and you have to do both of them. Okay, so here we go. Verify that the functions are inverse functions. So I have f and g. So first, I'm going to go f compose g of x. Now, we don't know that they're inverses. Well, we kind of do because it says verify, but so they're kind of telling us, all right, these are inverses, but you don't always know. But if they're going to be inverses, then this has to turn out to be just x, okay? So you can write it as f of g of x, like we did before, a few videos ago. All right, so I'm going to take this g function and I'm going to put it into the f function, okay? You can write that as f of x plus 3 over 4, if this helps. And then that's going to be, okay, oops, there it goes, 4 times, but I'm not going to put in x, I'm going to put in x plus 3 over 4. And then minus 3. Okay, so you're replacing in the f function x with x plus 3. All right, what happens? Those 4's cancel. You get x plus 3 minus 3, which is just x. And that's supposed to happen. Okay, so we're showing algebraically that they're inverses. We're verifying them by doing these compositions. Okay, now you have to go the other way. So now we're going to go g compose f of x. Or you can write that as g of f of x. Or you can write that as g of, now I'll use a different color to see if that helps explain it a little bit. Now what's f of x? 4x minus 3. Okay. And so we're going to write that as, now I'm using g, so it's something plus 3 divided by 4. And what is that something? 4x minus 3. Okay, now how do you do a problem like that? Well, first you take off those parentheses. So you'd have 4x minus 3 plus 3 over 4. Those 3's are going to cancel. You've got 4x over 4, and that's just going to equal x. So that's how you verify that two functions are inverses. You have to compose them. You have to do them both ways. Okay? All right.